Welcome to our exciting second lesson in Chapter 8. Here you'll see me actually graph things. So we're going to be graphing simple rational functions today. Simple, in the case of rational functions, means that the shapes will all be hyperbolas. We saw what a hyperbole looked like in 8.1. We're going to have asymptotes. We're going to have to draw it in two halves. But these shapes are all going to be about the same. Some of them are stretched and some of them are moved. So the three basic ways we graph hyperbolas, three forms we have for this. The first one is just inverse variation, y equals a over x. It's the simplest. It's going to have its vertical asymptote and horizontal asymptote on the axes every time, so it's just a matter of plotting a few points to make sure we get the curve right. The second thing we're going to graph is a transform version of our inverse variation. We've got a x minus h on the bottom and a plus k on the outside. That's going to translate. It's going to move the graph to a new location. So the asymptotes will be moved. Then again, we'll find a couple of points to get the curve right. The third version is also a hyperbola. It's got a linear expression on top and on bottom, which is going to change the way we approach things. But I have it laid out nice for you. I'll show you 4 basic steps, which we'll use today for this form. And also, those will be the same 4 steps we use moving forward into the more complicated rational functions. So we'll get used to those 4 steps as we practice them. So let's move to the first graph, y equals a over x. In this case, a needs to be a number. So for our first example, let's use y equals 4 over x. Pretty straightforward. As I said before, since this is inverse variation, we know we're going to have the vertical asymptote on the y-axis, and we're going to have the horizontal asymptote on the x-axis, so there's no need to find them. We just write x equals 0 here, and y equals 0 here, and we're good to proceed. We need a few points to fix the curve. It's just a matter of sticking in x's. You do want to pick x's that will give you nice answers, so you can pick whatever you like, but you'll get fractions, and I think you probably don't prefer to graph fractions. So if we stick in 1, 4 divided by 1 is 4. If we stick in 2, 4 divided by 2 is 2, and if we stick in 4, 4 divided by 4 is 1. Nice and easy. Like I said, you can stick in other points and get your fractional values and graph those. It won't offend me. We need to be prepared on the left side as well. You can stick in negative values. 4 divided by negative 1 is negative 4. 4 divided by negative 2 is negative 2. And 4 divided by negative 4 is negative 1. These graphs are symmetric on their axes. On their asymptotes. The inverse variation, the asymptotes of the axes. So you're going to find they're perfectly symmetric here. We come from this asymptote at y equals 0, which is a line we're going to approach but never actually touch. So we come up from there through our 3 points up to our vertical asymptote here. And the same thing on the left, from one asymptote through our 3 points to the other. That's not a very good curve, is it? It's really okay if your curves don't look great. I find it's easier to draw the curve when you're following the curvature of your wrist. So you might find this one's a lot easier to draw if you rotate your page, which I probably should have done, but I didn't. So remember where the vertical and horizontal asymptotes are. Find yourself a couple of points to get the curve right, and you should be able to draw these graphs. The larger a is, the further away this graph will be from the origin. The smaller a's mean you'll be closer to the origin. Let's move on to our second form, which is the transform version. For this example, we'll be using y equals negative 3 over x minus 1 plus 2. I'll draw my axes to prepare. The minus 1 here means that h is 1. So when you have h of 1, the graph is going to be moved one space to the right. Remember, the one next to the x is always backwards. So the -1 is actually means that h is +1. So we're going to move one space to the right. That moves our vertical asymptote from x equals 0 to over here, x equals 1. So I draw a dotted line, call it x equals 1. That's my vertical asymptote. The +2 on the outside, that's k. It's going to move my graph up 2 spaces. It's not backwards. So +2 is up. If that were -2, I would go down. So the horizontal asymptote will always be where k is. Notice x equals 1 because x equals h, and y equals 2 because y always equals k. That's how you're going to find the horizontal and vertical asymptote in this case. Draw this all the way over. Now we just need a few points. Again, pick your points strategically and you'll have an easier time of it. Things that divide 3 nicely are 1 and 3. So I'd like to make the bottom 1, which I can do by sticking in 2. That gives me -3 over 1 plus 2. -3 plus 2 is -1. If I stick in, say I want also the bottom to be 3, which I can get by sticking in 4. 4 minus 1 is 3. So -3 over 3 plus 2 is -1 plus 2 is 1. On the other side, I can make the bottom equal -1, which I do by sticking in 0. So when I stick in 0, I'll get -3 over -1 plus 2, which is 1 plus 2 is 3. And if I stick in -2, -2 minus 1 is -3, so that'll give me +1. Oh, I did that wrong. -3 plus 2 is +3 plus 2 is 5. I apologize. That should have been 5. This one is 1 plus 2, which is 3. Right, I apologize. Okay, 2, -1 is right here. 4, 1 is here. Notice this one is just a little bit closer to the center of the asymptotes because a is 3 rather than 4, but it's not too much closer. So I can come up here through my 2 points to my other asymptote right there. Similarly, let me graph the points first. 0, 5. Notice this is actually symmetric based on the asymptotes. It's 3 up and 1 over. This one was 1 down and 3 over. So this is symmetric, but not about the origin. It's symmetric from the center of the graph. Similarly, -2, 3 is also symmetric. I'm going to go ahead and rotate my page this time. Hopefully I'll get a nicer curve that way. So come up through my 2 points to my asymptote. That was much better. So here's the graph of -3 over x minus 1 plus 2. Remember, find the asymptotes using h and k. Find a few points, draw your graph. For our third example, we will be using y equals 3x minus 6 over x plus 2. It's linear on top and bottom. As I indicated, this is going to take a little bit more work because we can't see h and k immediately. But there's 4 simple steps to follow. That'll give you all the information you need. The first step is to find the vertical asymptote. The vertical asymptote will always occur where the denominator equals 0. You're not allowed to divide by 0. That's what produces the vertical asymptote. So when we set the bottom equal to 0, we're going to figure out where that happens. So let's do that first. 1. Set the denominator equal to 0. X plus 2 equals 0. Which means that x equals -2. That's our vertical asymptote, -2. Our second step is to find our x-intercept, if there is one. There's not always one. But you find the x-intercept by trying to make the top equal 0. 3x minus 6. In this case, there is one. We're going to be able to solve this equation. But sometimes you'll find the equation can't be solved. Then there'll be no x-intercept. But in this case, 3x equals 6. So x equals 2. That's our x-intercept at x equals positive 2. Our third step is to find the y-intercept. It's arguably the easiest step. All you have to do is stick in 0 for the x's and find the y that goes with them. So 3 times 0 minus 6 over 0 plus 2, which is negative 6 over 2, negative 3. So y equals negative 3 is the y-intercept. That's where we're going to cross the y-axis. And lastly, we're going to divide the leading coefficients to find the horizontal asymptote. Now this will work because these are both linear. When we move to 8.3 and they're not necessarily both linear, we'll actually have a more complicated version for step number 4. This is one of the cases. But in this case, the top is 3, the bottom coefficient, leading coefficient, is 1. 3 divided by 1 is 3, so that's our horizontal asymptote at y equals 3. Let's use these 4 pieces of information to sketch our graph. It should be sufficient, so I'll draw a set of axes here. Our vertical asymptote we have already found to be at negative 2, so I'll draw that first. For here, x equals negative 2. Our horizontal asymptote is at y equals 3. That is up here. Y equals 3. Our x-intercept is at x equals 2. And our y-intercept is at negative 3. So that's right here. I'll come up here from my asymptote then, through my y-intercept, through my x-intercept, and to the next asymptote. This graph is also supposed to be symmetric, so you can actually plot the other points by figuring out how far away they are, or you can stick in x values. In this case, I'm going to stick in negative 4, because that's the distance that I have to go to get to the other side of this asymptote. When I stick in negative 4, I'll get 3 times negative 4 minus 6 over negative 4 plus 2 is negative 12 minus 6 over negative 2. Negative 18 over negative 2 is 9. So negative 4, 9. And there's my point. You can find the other one by sticking in negative 6. I'm not going to, though. I have enough information to draw my curve. Now that I've seen the other side, 1 point, it should be enough. Although, after my success last time, I'm going to rotate my page to draw this curve. It's going to go through this point. Oh, it's going to head off the edge there, which will do for now. So we've got a horizontal and vertical asymptote plotted, and we have our hyperbola drawn. This should be enough to get you started. You can go back over these. You might want to write down these 4 steps. Maybe if you pause the video, you'll be able to see them long enough. We're going to use these 4 steps next lesson, so maybe keep them somewhere safe. This should be enough to get started on your homework. Make sure you ask if you have any questions.